I am Anil Kumar. Welcome to my YouTube channel and the website Global Math Institute. In this video, we'll consider how do we find the exact values of trigonometric ratios. We'll use the special angle triangles for the same. We'll also see the application of unit circle to find values of trigonometric ratios for different angles. Our approach, engaging minds, helps students think creatively and solve problems strategically. It helps them to connect with the context, visualize strategies, apply learnings, and bridge the gaps. Join Anil Kumar classes, gain confidence, and get ready for future. We develop mathematical and social skills for excellent performance of our students. The gift of education. I can be part of your success story, build strong foundation, ensure bright future. Join Anil Kumar classes, send an email on the address given here. Let us now enjoy the class with Abhinav. Hi Abhinav, how are you doing?
I'm good. How are you?
Very good, very good. So Abhinav, today, what do you want to do?
Gonna start trigonometric functions and
Okay,
trigonometric graphs.
ratio. Okay, and graphs. Okay, that's fine. So Abhinav, can you please introduce yourself?
Yeah, my name is Abhinav. I'm in Math 2 currently, and I'm in 8th grade.
Great. So eighth grade and doing trigonometry of that level. Very good. So we'll actually begin with basics. Okay. So
Yeah.
I'll start from the very basics. I know you know quite a bit of it, but we'll just review these concepts and then move forward. Let me share with you a whiteboard to begin with. So you know about the sine, cosine, and tangent ratios, right? So
Yeah.
let me write these ratios here. Let's say what is sine theta equals to? Sine theta is opposite over hypotenuse, correct?
Yeah.
Cos theta is what?
Adjacent over hypotenuse.
And tan theta is what?
Opposite over adjacent.
Correct. And normally we write this in a very short form and we say, well, sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tan is opposite over adjacent, right? So
Yeah.
SOHCAHTOA is a good way to remember. So it's kind of an acronym for this, right?
Yeah.
So we really mean that if I make a right angle triangle, let me make a right angle triangle here. If this is a right angle triangle, that is to say right angle at this point, and let's say this angle is theta here, then if you look from the angle theta, then which is the opposite side? It is this side which is opposite, right?
Yeah.
And this side is hypotenuse, correct?
Yeah.
And that ratio is sine theta, right?
Yeah.
And the adjacent side is always the side which is between the angle and 90 degrees. So this is the adjacent side when we talk about this, correct?
Yeah.
Now let me give you another triangle which is also considered to be a special triangle since those values are 30, 60, 90. So 60 degrees, 30 degrees, and 90 degrees. In this triangle, if I complete the drawing is not to the scale, but if I complete the triangle, let us say that each side is 2 units, right?
Yeah.
In that case, this perpendicular will divide the base into equal parts, right?
Yeah.
Therefore, each will be 1 unit long. What will be the altitude or the height? It is 2 square minus 1 square square root, right?
Yeah.
Pythagorean theorem. So it is 2 square minus 1 square square root, which is square root of 4 minus 1, and that is square root 3, correct?
Yeah.
So in this particular triangle, which is 60-degree triangle, we have found that the sides are in the ratio of 1 is to 2 is to square root 3, kind of, right? So let me write down these values as A, B, and let us say this point is C for us. In that case, can you tell me what is sine of 60 degrees?
Okay. Sine of 60 degrees is radical square root of 3 over 2.
Very good. Opposite side, which is square root 3 over 2. And what is cos of 60 degrees?
Okay, so cosine of 60 degrees is 1 over
2.
2. 1 over 2
And tan of 60 degrees
is radical 3
is? Yes.
over 1.
Radical 3 over 1. So it is radical
Yeah.
3. Correct. So that is how we can find the angles in a given triangle. Right? Now let me take you to the next exercise. Then this length is x and this length is y. Correct?
Yeah.
Let me write this point as q. So what is OP equals to? Let's call this R. This R is equal to how much? Use Pythagorean theorem. X square plus y square square root. Correct?
Yeah.
Right. Now, if this angle is theta, then what is sine theta equals to?
Y over R.
What is cos theta equals to?
X over R.
And what is tan theta equals to?
Y over X.
Is that clear to you?
Yeah.
Now let us consider another triangle where the point P is at such a distance that R is equal to 1. So P is equals to, let us say, some point, right? AB, right? So that R is equal to 1. So that R is equal to 1. Is it okay?
Yeah.
That is to say, I'm saying A square plus B square square root is 1. This is what I'm saying. So if
Yeah.
I have this point, in that case, what is the value of sine theta if R is 1?
Y.
Sine theta is the y value B, right? Do you understand?
Yeah.
And what is cos theta? X value A, right?
Yeah.
And tan theta is the ratio of B over A. Is that clear to you?
Yeah.
You get the idea? If R
Yeah.
is 1, in that case, sine theta gives you directly y coordinate value, right?
Yeah.
That is what I'm trying. Now, 1 unit away means what? Let me show you. What is 1 unit away? I'm showing it here. 1 unit away is this point is 1 unit away, right? 1, 0, correct?
Yeah.
So we can make a circle. This point is 1 unit away, 0, 1, correct?
Yeah.
We call this as a unit circle because the radius is 1 unit, correct?
Yeah.
So any point on this circle will be 1 unit away. So for this circle, x values will be. Now let's consider any point on this circle. So I'm saying point will be x and y, any point on unit circle. In that case, sine theta is the y value, cos theta equals to x value, and tan theta is the ratio of y and x, right?
Okay.
Tan theta is the ratio of sine and cosine. This is what you have learned in a
Yeah.
unit circle. Does it make sense to you?
Yeah.
Is that clear? So for this, when you are at this, that means this thing collapse, right? The angle is 0, right?
Yeah.
And this is 90. For 90 degrees, sine is 1, cosine is 0. Because then this point P will come here, right? On the
Yeah.
y-axis. Only then you'll get 90 degrees, correct?
Yeah.
Is this part clear to you?
Yeah.
Very good. Now let's move forward. I'm clearing this. So now we'll again fill the table with special triangles. Is that clear to you?
Yeah.
So we'll have sine theta, cos theta, and tan theta. And from there, we are going to learn a few more things. So this is for 0 degrees, 30 degrees, 45, 60, 90 degrees. And we're talking about sine theta, cos theta, and tan theta. And 0 and 90. 0 and 90 is very easy to get from the coordinate points, right? Because for 0 degrees, my coordinate point is 1, 0. That means for 0, sine is 0 and cos is 1, right?
Yeah.
For 90 degrees, my coordinate point is 0, 1. That means the y value being 1 and x value being 0. It is cosine, correct?
Yeah.
To get 30, 45, and 60, I will make right angle triangles. So we just looked into one equilateral triangle. In an equilateral triangle, if each side is 2 units, in that case, if I drop a perpendicular, it is going to bisect and each side will be 1 unit, correct?
Yeah.
And the altitude will be square root of 3. The angles will be 60 degrees, half of 60 is 30, and then 90. That means 180 in all. So we do have a triangle which is 30, 60, 90, right? So we have a triangle which is 30 degrees, 60 degrees, and 90 degrees, correct? A special triangle. From this triangle, we can find the value of sine theta and cos theta if theta is 30 or 60 degrees, and also tan theta. Let's do sine and cosine first. Sine of 30 degrees is how much? So 30 degrees means look from here. Is that okay?
Yeah.
Opposite side of 1, hypotenuse of 2. So it is half, correct?
Yeah.
What is the value of cos 30? Tell me.
Um. So radical 3
Yes,
over 2.
correct. And tan theta, opposite over
Uh,
adjacent.
so 1 over square root 3.
Now you'll also notice that this is ratio of sine and cosine. We'll get to this later. Now let me make another triangle which will have 45 degrees angle. So if I make an isosceles right triangle, means the two sides are equal, and if these two sides are, let us say, 1 and 1, in that case the third side is 1 square plus 1 square square root, which gives me square root of 2, right?
Yeah.
Diagonal of a square basically, correct? So in this
Yeah.
case, the angle is 45 degrees. So for a 45 degrees, 90 degrees triangle, I can find sine and cosine. Can you tell me what is sine for 45 degrees?
1 over square root 2.
Cos
1 over square root 2.
and tan
1.
1. Perfect. Now let's get back to 60 degrees. So 60 degrees means we are looking into this triangle from angle 60. What is sine of 60 degrees?
Uh. Right. Square root 3 over 2.
And cosine of 60 degrees?
1 over 2.
And the tan of 60 degrees.
Square root 3.
Got it. So we have filled up our table. Now, you have to tell me what is tan of 0 degrees?
0.
Correct. And tan of 90 degrees? Look here.
1.
Y over 1 over 0, which is undefined, so infinitely large. Do you see it is not defined? So
Yeah.
tan, so what you learn is from here, tan theta is basically equal to y over x value. Do you see that?
Yeah.
So x value is 0. So basically tan theta is actually speaking sine theta over cos theta. So if you divide 0 by 1, you get 0. If you divide 1 by 0, you get infinitely large, correct?
Yeah.
You could also do and check your answer for 30 degrees, 60 degrees, and 45 degrees. The ratio of sine and cosine is tangent. So we have learned here one more rule, which is an identity, and that is that tan theta equals to sine theta over cosine theta. Is that clear to you?
Yeah.
So, so that completes all our angles from 0 to 30 degrees, and the measurements are the values are given to us in, we call them exact values. Is that clear? These are the exact values, correct? No
Yeah.
decimals. These are the exact values. Now, many times, 1 over square root 2 will be rationalized by multiplying by square root 2 and dividing by square root 2. And you get this as square root 2 over 2, correct?
Yeah.
So, many times we will rationalize it. Similarly, 1 over square root 3 can be written as what? Square root 3
Square
over
root 3.
3. So, remember this, that many times we have to rationalize our answer to write in proper way. Radicals should be rationalized. Okay,
Okay.
perfect. So we have calculated the exact values from 0 to 30 degrees for our sine, cosine, and tangent ratios, correct?
Yeah.
Okay. Now let's move on to the next exercise, and that will be, we'll now find the angles from the given situation, right? So, and we will use general triangles, right?
Okay.
Use calculator.
Okay.
So, if I have sine theta equals to, let us say 0.6879. So, what is theta equals to? How will you find this value?
Uh, you can draw a triangle, and I can
You
put.
do sine inverse of this using calculator. So, I would like you
Okay.
to see, do you have the calculator?
Yeah.
Use the function sine inverse to find the angle theta. We know sine theta is 0.6879.
Yeah.
So, so the mode should be degrees, which is the default mode, and
Yeah.
shift sine, and then put in 0.6879, enter, and you get 43.46, right?
Yeah.
Which you can round to one decimal place as 43.6 degrees. Is that clear to you? So
Yeah.
that is how you can use the calculator and find the answers which are not for exact values, right? Not 3069. Is that clear to you? So let's
Yeah.
do some of these now quickly. So I'll write down and you have to tell me the angle theta, right? So let's say cos theta is equals to 0.2456. So find what theta is equal
Yeah. I got 75.78.
to. Okay. Tan theta is equals to 3.46. What is theta equals to?
73.87.
Now one question. The question for you is, let me write down the values. Let's say sine theta is equals to 1.245. What is theta equals to?
Okay. Yeah, it says error domain.
Why? Why does it say error? Tell me.
Because
Sine is a ratio of which two sides?
opposite over hypotenuse.
Hypotenuse is the longest side. Do you see that? So this ratio cannot be greater than 1, correct? It is
Oh
always
yeah.
less than 1. Do you see that?
Yeah.
So that is why it's an error. So this value of sine theta is always less than 1. Do you understand?
Yeah.
Maximum is 1. That is why it was an same is the case with cosine. However, tan is ratio of opposite and adjacent, these two sides. So it could have any value, correct?
Yeah.
Very important thing to understand. Okay, now let's get back to our standard special triangles. You remember the special triangles? So we'll do a quick exercise of using these triangles and then finding some exact values. Is it okay?
Yeah.
So here we have 30, 60. I'm just drawing for your reference so that you can easily read the values from the given triangles. Find what is sine of 30 degrees times cos of 60 degrees times tan of 30 degrees. Tell me.
Okay. So it's
No calculator allowed, straight away.
okay. So it's 1/2 times 1/2 times 1/radical 3.
So you get 1 over 4 radical 3, correct? I would
Yeah.
like you to rationalize this and tell me the answer.
Okay. It's radical 3/12.
Correct. So that is how you could calculate this answer. Is that clear to you?
Yeah.
Correct. So we'll do one more question. So we'll do sine theta cos theta minus. Oh, sorry. I'll I'll change the value. We are trying to find sine 60 cos 60 minus sine 30 cos 60. Tell me what is the answer for this?
Okay. So it'd be radical 3/1. So radical 3 times 1/2.
Correct. So we are talking about this angle, and so
Yeah.
we should always have a triangle handy. So sine 60 is square root 3, and this is
One over.
half, correct? And this is sine 30 is this angle, which is 1 over radical 3, and that is cos 60. I wrote again, okay, so that's fine, right? So you can figure out what the answer is, right? So the common denominator is 2 square root 3, and sorry, yeah, 2 square root 3, and the numerator is what? In this case, you have to multiply by square root 3 minus, and this is 1, right?
Yeah.
So which is 2 over 2 square root 3 or is equals to 1 over square root 3, correct? Which can be rationalized and written as square root 3 over 3, correct?
Yes.
So you could do some manipulations like this and find the exact values of an expression which has some of these involved in it, correct?
Yeah.
Correct. So let's do this. Tan of 30 degrees minus sine of 30 degrees divided by tan 45 degrees plus cos of 30 degrees. Tell me what is this?
Okay. So on the numerator, it's 1/radical 3 minus 1/2. And denominator, it is 1. I mean, yeah, 1.
Yeah, one.
1 plus 1 plus radical 3.
Over
1
2.
plus radical 2.
Right. This is what. So you need to simplify this expression, correct? To simplify, you have square root 3 times 2. You can multiply and then you can simplify, right? So what do you get?
2 minus radical 3 over 2 radical 3 plus 2 plus 3 plus 3.
Plus 3. So that is what you get. So this is how you can actually simplify these expressions, right?
Yeah.
Okay. Now, let us look into the cases when our sine theta is more than 90 degrees. Okay.
Okay.
Let us say, rather, let me just do it like this, theta being between in the top half, top half. So here we have a point P whose value is xy, correct? And we define this as our angle theta, right? Now this
Yeah.
theta is considered positive if we move counterclockwise. Do you understand? From
Yeah.
positive x-axis. So this is called the initial arm, and that is called the terminal arm. And the angle made, if it is moving counterclockwise, is positive. Now, if my value of, if this comes to this point, and we have another point Q here, and let's say, so what is the coordinate values of Q here? It could be, let us say, xy. So in this case, for the angle, this angle, which is more than 90 degrees, what is sine theta equals to? We know sine theta, let us say the distance is r away from 0. Is it okay?
Yeah.
So sine theta is y over r, correct? And cos theta is x over r, correct?
Okay.
In general, that is true. But now think about second quadrant. So this is quadrant 1. In quadrant 1, all are positive, right? This is also positive. This is also positive, correct?
Yeah.
But in quadrant 2, the x value is negative and the y value is positive, right?
Yeah.
Because any point in quadrant 2 will be like minus 3 plus something, correct? X value is negative. So in
Yeah.
that case, the cos theta value will be negative, right? And the sine theta value will be positive. Do you see that?
Yeah.
And now, since tan theta is ratio of sine and cosine, means tan theta is y over r x, right? That will also be negative, correct?
Yeah.
So now you have understood the logic. You have seen how sine theta, cos theta will change from different quadrants. So you have to
Yeah.
summarize this learning on this particular page. So we are looking into the coordinate system. And in a coordinate system, we have four quadrants, right? Quadrant 1, quadrant 2, quadrant 3, and quadrant 4. I know one thing, that any point P with general value of x and y really tells me something, that sine of this angle theta will be equals to, if this distance is r away from the origin, is y over r. And we know r is positive, right? R is
Yeah.
always greater than 0. Is it okay?
Yeah.
Cos theta is x over r, and tan theta is equal to y over x. So now you tell me which value is positive, which I have to find the sine let us say we find the value of sine theta. Is it positive or negative? Cos theta, positive or negative? Tan theta, positive or negative in quadrant 2? Tell me.
Okay. Okay. So sine theta is negative.
No, sine theta is y value. Y value is positive.
Okay, okay, yeah. Cos theta is negative, and tan theta is negative.
If I move to the other quadrant, how will this change?
Okay.
Tell me.
Sine theta, sine theta is negative, cos theta is negative, and tan theta is positive.
Tan theta
And
now becomes positive. If I
yeah,
go to the quadrant 4, then what becomes positive?
okay. So sine theta becomes negative, cos theta becomes positive, and tan theta becomes negative.
Correct. Mainly because any point here will have positive y value but negative x value, right? Any
Yeah,
point here has both negative coordinate points, and here it is positive and negative, right? Y value is negative. So the ratio, when the signs are different, is negative, which gives you the sign of tan. So from here, you understand that in each quadrant, we can figure out the sign of each trigonometric ratio. Here you can see that all are positive, right, in quadrant 1, since
yeah,
both are positive, right? So ratios. But in quadrant 2, only sine is positive. In quadrant 3, only tan is positive. And in quadrant 4, only cosine is positive, correct?
yeah,
This is called the cos rule. Do you understand the cos rule now?
yeah,
And the reason why it is so, correct? This is very important. That's why have a good look at it. Remember this part.
yeah,
It's a very important point. We know sine, cosine, and tangent can be directly found from the coordinate point.
yeah,
Sine value being y over r. R is the distance from the center of that point. Cosine being x over r, and tan will be the ratio of y and r. Since x, y value, the coordinate points, are both positive in quadrant 1, all trigonometric ratios are positive in quadrant 1. In quadrant 2, y is positive, x is negative. And therefore,
yeah,
cosine is negative, sine is positive, and tan is also negative. In quadrant 3, both x and y are negative. So both sine and cosine are negative. However, their ratio, tan, is positive. And in quadrant 4, x value is positive, y value is negative, cosine is positive, sine is negative, and their ratio, tan theta, is negative. Correct?
yeah,
Now that helps us to give a very big picture. And that is, we began with 30, 60, 90 degrees angle, right?
yeah,
Let me redraw. And we'll write down the angles, right? So let's say, let me start with 45 degrees first, diagonal. So that is 45 degrees, right?
yeah,
And now we will sketch 30 degrees, which is less than 45.
yeah,
And now we are going to sketch 60 degrees, which is more than 45. That's the whole idea, right? Give you an
yeah,
approximate value. Let us say we are 1 unit away. Let us say I make a circle which is only 1 unit radius. Is that okay?
yeah,
So is that correct? Let me have this circle 1 unit. It really means that this point is, for me, 1, 0, right?
yeah,
This point is 0, 1. This point is minus 1, 0. and this point is minus, uh, I mean, 0 minus 1, right?
Yeah.
So that is my circle. Now, clearly, you know the sine, cosine, and all values, right?
Yeah.
So, depending on the sine, cosine values, for sine values, your y value, cosine is the x value, correct?
Yeah.
You know your special triangles. Let me just draw for reference special triangles here.
Yeah.
We'll actually make all the values on a unit circle in a minute. So this is 60 degrees. The sides are 1, 2, square root 3. 45 degrees. Sides are 1, square root 2, 1. Right.
Yeah.
Perfect. Now, so what is the xy value here? Can you tell me? Just as in the coordinate x-axis, I have 1, 0. Can you tell me this value?
1 0.
No, not this value. This value at 30 degrees angle.
1 1.
No, 30 degrees on the unit circle. If you look from 30 degrees, sine is half, but cosine is square root 3 over 2. So this is square root 3 over 2, and the x, this is the x value, cosine value, and the sine value is half, right?
Yeah.
For 45 degrees, what are the values? 1 over
Okay.
square root 2 and 1 over square root 2, correct?
Yeah.
Not really, not really. Sorry, because this was 2 here, right? So I have to make radius as 2, so I have to divide by 2, right? Half of this.
Okay.
Well, I do not want, I want to, uh, uh, half of this means one half of this, correct?
Okay.
Because unit circle means I don't want 2 here, I want 1, correct?
Yeah.
So I'm dividing each side by 2, correct?
Yeah.
And in this case, I'm dividing each side by, because I don't want square root 2, I want 1, right? So I'm dividing everything by square root 2. Is it okay?
Yeah.
You get the idea.
Yeah.
Okay. Let me redo, so that it's absolutely clear.
Yeah.
So
You
what
only
I'm,
want one.
yeah,
You
I
want
only
one.
want 1, right. You get the idea.
You're just multiplying by the denominator.
Yeah, I only want 1. Yes. So in that case, if I want this 1, then I have to divide everything by 2, right?
Yeah.
For an angle of 60 degrees. Similarly, when I draw the other triangle, which is 45 degrees triangle, if I want this as 1, not square root 2, I have to divide all these sides by square root 2, correct?
Yeah.
Now, based on this, on a unit circle, so we are calling it a unit circle. I can calculate all the points. Now, for 60 degrees, what is my point? The cosine is the x value, right? So,
Yeah.
which is 1 over 2, right?
Yeah.
And sine is the y value. For 60 is square root 3 over 2. Do you understand?
Yeah.
And for 90 degrees, I already had my value, correct?
Yeah.
Now, from the symmetry, can you tell me the points on this side?
Okay. -1/2. Negative uh radical 3/2.
Perfect. Both are negative. This is what we are trying to say, right?
Yeah.
Tan is negative. And this point,
-1/√2 and then -1/√2.
45 degrees. You're right. Both negative. And this point,
Negative √3/2 and -1/2.
does it make sense to you? From
Yeah.
the 5 values which we calculated, we could actually get all the values through the circle, right?
Yeah.
Now look here. Let us look into this quadrant now, correct? So let me draw another green line which indicates 30 degrees from here. Now this angle is 30 degrees. We call this as a related acute angle. Acute angle, you understand, is less than 90 degrees, right?
Yeah.
So from the symmetry, can you tell me the coordinate points of this?
Yeah.
Tell me.
Negative radical 3 over 2, comma 1 over 2.
Perfect. Y value being same because sine theta is same, positive. That means I could get this value also, right?
Yeah.
Tell me.
Radical 3 over 2 minus 1 over 2.
Perfect. So now you can actually give me all the points on this unit circle for different angles. You get the idea?
Yeah.
So that is your homework now. So what you do here is that you can complete your unit circles, and so easy it is. From the first five which we calculated, you know all the angles, correct? And you can confirm that all are positive here. Sine is positive here. Tan is positive in quadrant 3 and cos is positive in quadrant 4, correct?
Yeah.
Easy. Simple. If you look at this point, this is a reflection. Exactly same, the x values become negative, and you say, well, minus 1 over square root 2, sorry, 2, half. And this is half, correct?
Yeah.
And here, when we are looking at this, I know that the x value is positive, the y value is negative. You get the idea?
Yeah.
So that is how you can complete your unit circle. Once you have unit circle, you have sine, cosine, tan values for all these angles. Because if you look at these angles, then what is the angle? What is this angle? Can you tell me?
Uh,
90 plus 45, 135, correct?
yeah.
Do you get the idea? What is
Yeah.
this angle?
150.
Yeah, 30 less than 180. So now you know values of so many other angles. Is that clear to you?
Yeah.
So that means you can now plot or find the exact values for, let me just put dot 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 here, for sine theta, cos theta, tan theta, for angles starting from 0, 30 degrees to full circle, 360 degrees, 30 and 30 degrees. You understand?
Yeah.
So this is your homework. Complete this chart with the exact values using unit circle. Perfect.
Yeah.
So unit circle directly gives us the value of trigonometric ratios, sine, cosine, and tangent, which we call primary trigonometric ratios. And actually, working for just 5 values in the first quadrant using 2 special triangles, we could get all the values, right?
Yeah.
Perfect. So this is very useful. I hope you remember this. I will now like you to summarize our learnings today. Yes, Abhinav.
Okay. So we started off with the basic trigonometric ratios like SOHCAHTOA, and
Yes.
then we solved problems using those, and we did inverse of SOHCAHTOA, like
Yes.
inverse sine, inverse cos, inverse tan, and then we did the unit circle, and we learned different values on the unit circle
Correct.
using special triangles.
Correct. And we found values of using special triangles for all the angles, not just from 0 to 90 degrees, right? Full
Yeah.
circle, right? That is the beauty. So we'll end the class here today and we'll continue. If there is any difficulty, do let me know. I'll share with you some more videos related to this later. Is it okay?
Okay.
Great. Have a great day. Thank you. Bye.
Bye.